Let us now try to understand how do we find exact solution of trigonometric equation when we are given a restricted domain and when we need to write a general solution. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll solve trigonometric equations where the domain is defined for us. It is a very important part of PreCalculus. The question here is, solve each equation for x between 0 to 2 pi, where 0 is included and 2 pi is not included. And for all real values, that means general solution. So what you're going to learn here is to find the solution within a defined domain and also to find general solution. Now once you understand the general solution, you could write the solution of trigonometric equation in any domain. You understand? Perfect. So 4 questions are there, all are related, they are in factored form, and we will see how do we write the solution of such equations. Perfect. Well, actually provide you with complete solution of question number 1 and leave the others for you to do and provide their solution in the next video. Sounds good? Perfect. Okay, so let's look into the very first question, which is tan 3x times 1 minus tan x. Well, in case you want to learn directly from me, send an email on the address given. So here is our first question, which is tan of 3x. It is written already in the factored form times 1 minus tan x equals to 0. We need to find the value of x, which should be between 0 to 2 pi radians, right? 0 is included, 2 pi is not included. And in part 2, we'll also find general solution. Is that clear? So clearly, when you have two factors and we want to multiply them to get 0, it really means that each one of them could be 0. So first let's see what happens when tan 3x is 0. Well, tan 3x is 0 when x is 0, right? And within 2 pi, 0 to 2 pi, we see that tan will be 0 at 0 and also at pi, correct? So these are the 2 points where tan is going to be 0. Now it is also written here, tan of 3x. Remember this part, tan 3x, right? So 3x, and we are looking into this terminal, x is between 0 to 2 pi. In that case, 3x will be between what? Times 3 gives us 0 to, times 3 gives us 6 pi. You get the idea? So that means we're not looking into just these 2 points, but we are also looking for their multiples, right? So there are more than 2 solutions, remember that part, since it is tan of 3x, not just x. And so we're looking for all the values from 0 to 6 pi, where 6 pi is not included. Clear? And looking into this, so what do we get? We get 3x as equal to, so this value is for 0 degrees, right? I should say radians, since we are working in radians, and pi radians, perfect. And then again 2 pi, 3 pi, 4 pi. So what you need to do is look into this, like continue going 3 times. Since this is tan 3x, remember this part, right? So I'm emphasizing on this point, as sometimes students only write just 2 solutions, right? And they lose all the marks. So 3x should be equal to 0, right? Should be equal to pi, then 2 pi, 3 pi, 4 pi, and also 5 pi. Look here, you should not include 6 pi since that is not in our domain. 2 pi was not in our domain. So for 3x, 6 pi will not be in our domain. You get the idea? And from here, we get the value of x, which is equal to, dividing by 3, we get 0. Divided by 3 is 0. Pi by 3, correct? 2 pi by 3. 3 pi by 3 means pi. 4 by the 3 pi, correct? And 5 pi by 3. Makes sense? So these are the solutions within 0 to 2 pi for tan 3x equals to 0 alone, right? Now we have to look for what happens when 1 minus tan x is 0 or tan x is 1, correct? Anyway, let me also provide you with the general solution for this part, right? So general will be what? Means any value, right? So basically we get x equals to, as you can very clearly see from this particular solution, that x is all the multiples of pi by 3, right? So n pi by 3. Makes sense? N pi by 3, right? Where n belongs to set of integers. Do you see that? So I'm just writing part solution. This is for tan 3x, and now in the next page I'll take up what is 1 minus tan x. And when is that 0, right? So once again, let's continue with this. We have tan of 3x times 1 minus tan x equals to 0. And we found one solution, that is 3x is equal to 0, pi, 2 pi, 3 pi, 4 pi, and 5 pi. And that gives us x equals to 0 pi by 3, 2 pi by 3, 3 pi by 3, which is pi, 4 pi by 3, and 5 pi by 3, correct? And in general, we got this formula as n pi by 3, correct? Now let's look into this part, which is 1 minus tan x. Perfect? So when will 1 minus tan x be equal to 0? That is when tan x is equal to 1. And when is tan x equal to 1? Well, in quadrant 1 and in quadrant 3. When angle is pi by 4 or 5 pi by 4, correct? As you can see. I will now like you to pause the video, answer the question, and then look into further solution. You still need to provide a general solution for this particular equation. Perfect? So there you go. So we have the solution because of the second factor also, pi by 4 and 5 pi by 4. You can always combine both the solutions and then write down your answer for solution within the interval 0 to 2 pi, where 0 is included but not 2 pi. Now it is time to think about how do we write this general solution. So I hope you got it. The general solution because of tan 3x equals to 0 should be what? It is related with pi by 3, you can see, right? So we can write this as n pi by 3, where n are integers, right? And because of the other factor, it is pi by 4 plus n pi. Perfect. So I hope with this video you have complete knowledge of how do we write solution for such equations given in factored form when we are looking for a solution within a given domain like 0 to 2 pi or a general solution. This can be extended to provide solution in any other domain also. Perfect? Now with this information, I'd like you to answer the other 3 questions in this particular video. I hope you enjoyed this journey of learning. Feel free to share your suggestions and comments. In case you want to learn from me directly, you can send an email on the address given. Here are the other questions for you to explore. We will provide their solution in our playlist soon. Thanks for your time and all the best.